not a new lesson. This is just working more with sum and difference identities and working more with the cofunction identities. So let's start off with the relationship between them, like sine of x plus pi. Now, we learned graphically that if we took the sine function and if we were to scoot it over to the left 180 degrees, like this point would go here, and so it would end up looking like this. So we know graphically that sine of pi plus x should be equal to negative sine x, but what we're going to do today is prove that algebraically, and we're going to prove it with the sum and difference identities. And so when you see sine of x plus pi, you should be thinking in your head that sine comes out sine, cosine, cosine, sine, and sine always has the same sign, so the plus stays a plus, and this is x, and this is pi, and this is x, and this is pi. So now the cosine of pi, I'm going to put that right here, that's negative 1, 0. The cosine of pi is negative 1. So this is sine of x times negative 1, and the sine of pi is 0, so that's 0, so that's equal to negative sine x. So in some of the examples, you'll be using the sum or difference in order to prove the cofunction identities. Here's another example of something that we learned graphically before, but we're going to prove algebraically today. So if I were to take the normal tangent function, it looks like this. If I were to apply the negative x to it, that would flip the tangent function over the y-axis. And then if I were to scoot it to the right 90 degrees, it will take that and it'll move it here, or kind of something like that. It will move it so it still looks like that, something like that. And we can see that that should be equal to cotangent of x. But now we're going to prove it algebraically. So tangent is sine over cosine. And sine goes sine, cosine, cosine, sine. And cosine goes cosine, cosine, sine, sine. And sine always has the same sign and cosine always has the opposite sign. And now I've left myself not enough room. So I will just squeeze them in. This is pi, this is x, oh sorry, pi over 2. And this is pi over 2, and this is x, and pi over 2, and x, and pi over 2, and x. And we've got a lot of pi's over 2's, so let's put that point, that's 0.01. So, remember tangent sine over cosine. So sine of pi over 2 is 1, so it's 1 cosine x, minus cosine of pi over 2 is 0, so that's 0, over cosine pi over 2, that's 0, minus sine pi over 2, that's 1, that's cosine over sine, that's cotangent. And that'll be about it for the lesson, except for I'll probably throw in a few simplification problems from the last chapter, along the lines of like sine x cosecant negative x. So this is sine x times 1 over sine of negative x, which will make you have to think that, well, think of the graph here. Sine of negative x. Okay, here's sine of x. And let's look at like this point at negative 180, and this point at positive 180, and this point at negative 90, and this point at positive 90. So the sine of negative 90 is the opposite of the sine of 90. So sine of negative x is equal to negative sine x, and so this is equal to negative 1. And that's pretty much it. I'll give you some problems you have to solve. Like, let's say you had to solve cosine of 2x is equal to 1/2. Well, you know, that means that the cosine inverse of 1/2 is equal to 2x. So find the angle that has a cosine of 1/2, and that's a 60-degree angle. And so the answer is 30 degrees. Another example of a solving function would be like tangent of x equals -1. So this is find the angle whose tangent is -1. And that would be a 45-degree angle, but it's got to be in the second or the fourth quadrant. So this would be 3 pi over 4 plus pi times k. So it's going to be 3 pi over 4, and it's going to repeat every 180 degrees. And then next class, we won't have a video, we'll just do a review assignment over all the solving functions and all of the sum functions, and we'll have a quiz probably at the end of class or the following day.